Yeah, sure.
Okay, here we go. Welcome to everyone who's joining right now, and welcome to the Deep Tech Showcase Microelectronics event. We're really excited to have everyone. So today's agenda, it's a one session showcase. So it's not the longest showcase we've ever had, and it's mostly focused on, microelectronics and semiconductors. So buckle up your seatbelts. We're gonna get going here. The vision, just for anyone who's joining for the first time, we are trying to help startups connect with the right stakeholders in government, investors, as well as corporations, with the goal of furthering technologies that otherwise would not, find a place. What we find a lot of the time is that there are really great technologies out there by very technical founders, and sometimes there's a hurdle between finding the right technology for the right places at the right time and finding the right people. So what we're trying to do is help create an ecosystem where, startups can get in touch to the right people at the right time so that these technologies can actually commercialize and hit the market. How we do this, we have events. So everyone here is on one of the events, which is awesome. And at the events, we usually have pitches. The pitches are usually 5 minutes, followed by 5 minutes of Q&A. And we really would love, first of all, to the panel, we love any kind of feedback, any questions. That's always a good thing. Even if it's negative feedback, that helps the startups down the road. So don't be shy. And then the other thing is, if you're in the audience and you really like something that you see, feel free to reach out afterwards. Usually the email is posted, or you can reach out to me if you can't find their email, can't find their contact info. Happy to help in that thing. And that moves on to our second point. We also help with guided introductions. So if you say, hey, Asher, none of these companies at this showcase necessarily were relevant to what I'm doing, but keep your eye out for X, Y, and Z. Let's say you're looking for, I don't know, some kind of printing circuit boards, right? High tech circuit board printing, let's say, right? You could let me know about that, and I can, keep my eye out. And I already have a few companies for that example, right? So happy to always make new introductions and help people, collaborate and get to where they want to be going. So our next two upcoming events, and we invite everyone who's here to, join those as well, is aerospace and defense and advanced materials. Both of those should be a lot of fun. And now, sorry, I'm getting ahead of myself. We're going to have Benjamin Sampson kind of give us a word from our sponsor. So Ben, the floor is yours.
Appreciate it, Asher. If none of you know, I am Benjamin Sampson. I'm Director of Business Development here at Eagle Point Funding. Just a little bit about us. I don't want to take too much time of Deep Tech Showcase's event. Just want to give you a little rundown of what we do. We're a grant consulting and a grant writing firm. What we do primarily is we work with deep tech startups who are looking to find and win non-dilutive R&D funding from the U.S. federal government, and work with them over 18 months to apply between 15 to 20 grants, SBIRs, STTRs, broad agency announcements, OTAs, whatever we can to help them succeed, we want to. And what we do really falls into three categories. So the first is we handle the sourcing of the grants. So we actually bring it to the companies. We bring the ideas of what we've got, what we think fits their technology best, what they have the highest likelihood of winning. We bring that to their attention. Then once they give us their okay, we obviously move on to actually doing the work. And the idea is by about 5-6 months into that 18-month relationship, we're handling as much of the technical documents, business proposals, the budgeting, formatting, laying it out, submitting to the agencies, communicating with the agencies, essentially whatever a client will let us take off their plate, we will, so they can go ahead and focus on their R&D and not have to worry about anything else. And that's really the goal for the 18 months. Now, while we're also doing all that, we're also helping, as Asher leads Deep Tech Showcase, we also help with a lot of the connections that are beneficial to really succeed on the grant side, whether it's from the corporate sector, whether it's from the government sector, whether it's from the investment side. Let us support MOUs, investment, pilot projects, procurement contracts, sales, investments, whatever it is, whatever we can help our clients secure to put their positions, their submissions into the most no-brainer position for an agency to approve. Well, it's beneficial to everyone. And I'll end off with this. We have a minimum success guarantee when working with our clients. If obviously we do due diligence on both sides, and if we decide to bring a client on, we're willing to extend to them a minimum success guarantee of $1 million in funding seen from the grants by the end of that 18 months. As you can see on this slide, there is a QR code that will take you to my calendar. Happy to book some time to talk with you about either you or some companies in your portfolio, some companies you may know of that could potentially be beneficial for them to go for grants, and just kind of talk to them, help them with some of the process. So I'm going to stick around for the next probably about 5-10 minutes. I'm going to throw the link to my calendar in the chat as well. And if you have any questions, please don't hesitate to send me a message. Not sure.
Perfect. Thank you so much, Benjamin. And feel free to leave your information in the chat. All right, now to get on with the presentation. So the first company presenting today, we have Silicon Core, followed by WaveWorks, followed by Accelerium, followed by Edmund Scientific. And now I believe we do have a bit of time. So without further ado, what I'm gonna do is I'm gonna stop sharing because boring slideshow presentations can be boring. And let's have some of the panelists introduce themselves and give a little quick hello, what you're looking for, what you're interested in, just to kind of get to know you guys. So we'll start with Jasmine. You want to quickly say hello and share a little bit?
Thank you, Asher. Hello, everybody. As of you old faces and new faces, I think Deep Tech is a great platform. And so I'd like to briefly introduce our investment strategy. To learn a little bit more about the technology today. So we are the venture arm of SK Hynix, and I am the investment director, one of the team members. And our company basically design and produce memory and storage chips for industrial and consumer electronic use cases. And our main products including DRAM, NAND flash, SSD, and image sensors, etc. And so currently we are seeking global opportunities at new and adjacent areas, such as emerging memory and storage technology, data center and infrastructure, and fabrication optimization solutions, AI, machine learning, etc. And any other deep tech spaces that are, could potentially address problems in data generation, acquisition, data transmission, and processing issues. So, and our typical check size ranges 3 to 5 million, depending on the growth stage and run dynamics. And so that's basically us. Happy to learn more about other peers and discuss more. Thank you.
Absolutely. Thank you so much, Jasmine. Next up, we have Tim.
Hey, good to meet you all. Tim Jones, located in Fort Collins, Colorado with Innisphere Ventures. We're a venture capital firm that does early stage investments in technology, in clean tech, life sciences, and we do some B2B SaaS. We're typically the first institutional investors in, average check size about 500K. We are associated with a nonprofit incubator that's executing on a National Science Foundation Regional Innovation Engine grant around climate resiliency, as well as a EDA grant in the life sciences space. So that's what we do. Good to meet y'all.
Awesome. Thank you for being here, Tim. Next up, we have Mark. Yep, go right ahead.
Hi, I'm Mark Pareka. Nice to meet everyone. I'm Mark Pareka. I'm the president of the Chemical Angel Network and one of the original founders of it. The Chemical Angels, we invest in hard science companies, and we focus on materials, measurement, and manufacturing. Our interest here probably is the overlap on the material side, because a lot of times it's the materials that really enable the interconnects, the low temperature solders, nonlinear optical materials. So that's our play in this space. And we're an angel network like any other angel network. We invest our own money in early stage, seed stage companies, and we are basically investing across North America.
Awesome. Thank you for joining us. Next up, we have Jonathan. Woo.
Hi, this is John from ITIC, the venture arm of ITRI. So we are the pretty much the largest research institution in Taiwan, and We also have a JV funds with Applied Materials that look at semiconductor equipments and also processes, materials, etc. And generally, we look at Series C all the way to Series A. Thank you.
Perfect. Perfect. Thank you. All right. Carolina. I don't think we'll circle back around. Next, bear with me, everyone. Martin, you wanna introduce yourself next?
Sure. Hi, I'm Martin, partner at Quest Venture Partners. We're an early stage firm based here in Menlo Park. We are generalists. We'll look at all kinds of stuff, but we're investing primarily in a lot of deep tech dual use things right now. We're super early. We can do check sizes from 300K all the way up to $1 million, $1.5 million. And again, one of our value add points is that we have deep ties to Japan. So large Japanese corporations, also Korean and Taiwanese corporations are either our LP or within our network.
Perfect. Elias, you want to guess?
Thank you. So my name is Elias. I'm with TDK Ventures, Deep Tech, CVC, part of TDK. We look at both energy transformation, so everything related to clean tech, climate tech. And on the digital transformation side, we'll look at industrial mobility, robotics, connectivity, and computing. Yeah, check size 1 to 3 million up to 5. Great to meet you all.
Perfect. Thank you. Thank you for joining us. Han, you want to go up next?
Sure, Han Ko here. How you doing? Everyone, good to meet you. And I see some of the familiar faces here too. So good to meet you. Good to see you. My company, Isaco Group. I'm a founder and president CEO. We are a VC investment company, just like everybody else. What's unique about it is that we are based out of USA. We have office in Los Angeles and Midwest and Texas, and a small office in New York. But also we have office in Seoul, South Korea. So we're very active globally, closely working with Asian markets, including South Korea and Europe. We have a strong interest in clean tech, AI, and also microelectronics and semiconductor field. That's why I'm here. And we like to invest in early stage to series, from early stage to Series A or B. So good to meet you all. Thank you.
Perfect. Thank you for joining us. Next up, we have Martin Aduboemi. Your turn.
Yeah. Hi, everyone. My name is Martin. I'm currently based in Seattle, and I'm with Microsoft on the hardware team. So essentially, we tend to look for emerging technologies that can help us reduce cost. So whether we can potentially partner with them or potentially invest in them, we do try and engage with them at the early stage. And prior to joining Microsoft, I was with DCVC, which is a deep tech firm based in Palo Alto, and happy to be here as well.
Perfect. Happy to have you. Thank you for joining. All right, Yvonne, you're up.
Hi, everyone. Hi, Asher. Thanks for being here again. So I am representing the Bosch Venture Group. We are an international venture team with offices in US, in Silicon Valley, in Boston, in Europe, in Germany, in Israel, and in China. And we do invest in mainly in technology startups from Series C to later stage. We do lead deals, we co-lead, we can follow. A typical check size for A and B is probably 5 to 8, up to $10 million US. And areas we like to invest in and we are looking at currently is photonics, connectivity, think data center, big topic. We look in logistics and supply chain. We look into some digital health topics, advanced manufacturing, robotics. You cannot say venture capital without generative AI today. Of course, we also look into semiconductor technologies, mobility, several climate tech topics, and also enterprise software.
Awesome. Thank you. Thank you for joining us today, Yvonne. Oh, all right. Next up, we have Mark Raczynski.
Hi, everybody. I'm Mark Raczynski. I am part of the strategic sourcing team at General Dynamics Mission Systems. Mission Systems is one of the 10 operating companies under General Dynamics Corporation. We don't make we don't build the submarines or the battleships or the tanks, but we build a lot of the technology that goes into them. Our solutions and technology range from things that crawl the ocean floor to things that ride satellites out of the galaxy. So unlike everybody else, I'm looking for things that are more near term to being commercially available and support mission critical operations. Very interested in things that are space rated as well as environmentally hardened for tough environments and climates. Looking forward to hearing everything. Thank you.
Perfect. Thank you for joining. All right, Alyssa, you're up.
Hi, everyone. My name is Elisa Band. I'm with Henkel Tech Ventures. We're the corporate venture capital of Henkel Adhesives. So from the name, we make adhesives, coating, sealants in the electronic space, semiconductor packaging, thermal management materials, bonding and sealing and coating technologies. And we're headquartered out of Germany. I'm personally based out of Connecticut in Rocky Hill, where our North American headquarters are. We look for startups that have innovative technologies in the spaces of our operating business. We connect the startups with their operating business to help establish those partnerships, collaborations, and then we strategically invest into startups. Our check sizes are between 1 to 5 million, with initial checks starting at around 1 to 2 million. We take board seats. We're very active in our portfolio companies, helping them reach their potential within Henkel, but then also outside of Henkel. Nice to meet you all.
Nice to meet you as well. Thank you for joining. All right, perfect. And that wraps up the panel introduction. So, Eric and Jim, or Jim and Eric, feel free to get going whenever you're ready.
Yeah, I am. Can you hear me?
Yeah.
Sure. Okay.
Yeah, loud and clear.
Okay. Should I share my presentation or
Yeah, go for it on your end.
Okay, cool.
Share.
All right. Hang on. Okay.
We see yeah, there you go. It's good.
Can you see? Yeah?
It's perfect.
Okay, cool. All right. Hi, everyone. This is Eric Lee. I'm the CEO of Silicon Core. Silicon Core is all about innovation and LED display. We're pushing the efficiency and the performance in both design and manufacturing. So I founded the company in 97. So the company is 28 years old. So we're not a startup. Our first product is a laser diode driver DVD recorder. As most of you probably use our product before. We used DVD recorder more than 14 years ago. Now we are LED display microelectronic component designer, and also we think we are assistant innovator. Over the years, we have created a lot of new technology in this LED display space, mainly in 5 areas, I would say. So common case technology, which kind of like driving the LED properly according to the threshold voltage. So it saves the power and bring down the temperature and long lasting. So it's a foundation technology we created in 2011. So and then second technology we call it ZAG. Basically, it's called impedance adjustment for color homogeneity. Basically, it's compensate the impedance variation among traces and LED, so it can achieve very good low bias uniformity and high time range, and therefore detailed image can be realized. That's about technology about 2016 or 2017. And then we develop a molding technology. So it's interesting. We're giving we're not just being a design company. We dive into the packaging area because it's packaging is important for LED display. So basically, we call a technology called LISA. We call LED in silicon array. Basically, it's a patented encapsulation technology that can protect the LED without reduce the brightness. So it can reduce. It can be a waterproof, ruggedized, high brightness, and also reduce the glare. So rather than viewing angle, so it's comfortable for people to view and very low failure rate in the field. In 2021, 22, Air Force, we fortunately got Air Force support to design a product so-called trusted display for U.S. Air Force. So we call it Lightning Protocol as well. It's a really so-called zero data retention display system. So when there's no memory in display, so it's a safe SQ for DoD to use. It's a SCI compliant. I very luckily execute everything flawlessly, and then since last year is in production. Now we are in phase 3 with U.S. Air Force. Last but not least, but it's a very important technology we developed so far called Prometheus technology. Basically, it's like Prometheus bring a little light to the wall where we kind of tend the light pulses of a LED. So it can produce very, very small light pulse. Therefore, you can have a very high frame rate, high grayscale, but at low cost and then low temperature, low power consumption. So it can enable multiple 3D screen, 3D at 3D on one screen, and can go down to very deep sub-millimeter display. So recently we got several awards. First one, I especially want to mention that we're fortunate to get award from the NAB show on the excellence in sustainability. It's really recognized our technology for last 13, 14 years. So it's very, very fortunate to get this award. And we also got a product award for the outdoor LED display last year at 1.2 outdoor highest resolution outdoor display in the world. And I have two very interesting projects accomplished in New York City. One is the David Cameron Hall. Everybody can go to Lincoln Center to see our screen. Another award is called One in Case. It's a 360-degree cylindrical display in One in Case, one of the bigger law firm in New York City. So we are kind of in position several multi-vertical at the moment, besides federal, which is recently more active to Silicon Core. We are also in a financial corporation. Citibank's our big customer. Microsoft is our customer too. I see the Microsoft audience here. So Microsoft Linden Store use our display. And then we'll be in education. We have a very big screen at Harvard Business School, USC. Recently Stanford for our customer as well. It be in control and command, so we sell display to Comcast. We're also active in the Booz Allen Hamilton, and then we also have a media in the entertainment area like ESPN, Fox, Wing, etc. So we are a multiple government funding winner thanks to this Eagle Point funding. I actually have a very close working relationship with Eagle Point funding for a lot of grant application over the years. So we almost $4 million winning from non-dilutive funding for SIBO, both from Air Force and Navy. And then we also one of the winner of called DBS from DoD, Defense Business Association award last year in 2023. There are 7 companies awarded, and we are the number 2 in the award amount of money. So future technology is what we are focused on. There are 3 topics we're working on. So one is so-called beyond RGB display. So basically 2 things. One thing is we want to display something invisible, for example, infrared. And then also maybe wider than red 2020 color gamma. So it's really to enhance the screen performance. So kind of do use infrared more like military, and then color gamma probably more for commercial. And then we have a very interesting proposal to DoD. We want to work on so-called infrared-capable AI-enabled situation awareness LED screen for both command control and also in the battlefield. Last but not least, working with MIT to develop head-mount display micro-LED projector screen, larger than 4,000 PPI, higher than 2 million NIC. It was based on 5-nanometer TSMC technology. We're going to develop the silicon substrate from the HDMI input all the way to LED driver. So that's our expertise. Future government project based on the technology, we focus on AI display, war gaming, either table or super formation war display, simulation, training for pilot, XR, for a submarine, and then wearable in the future, and HMR display in the future as well. Future vertical, similarly, from the technology we think will more federal project, simulation, training, battlefield available. We hope we can get into that market. Edge AI application in the wearable, and finally, HMD with micro LED display.
30 seconds.
So thank you. So in terms of manufacturing, we think we need to move production onto America. So phase 1 probably more like assembly, mechanical. Phase 2 more like PCB manufacturing. encapsulation. Phase 3 is more advanced COG or chip on silicon COS development. So financial-wise, we are profitable this year. I think we got about $25 million on the big company. And then, but we are active R&D. Lots of government help us to do the R&D. So we target to win another $3 million CBER in this year. So growth of probably about 30% from next year. Many from the DoD and government-related project going to phase 3. So what we're looking for private funding partner to continuous R&D and onshore America activity. With the matching fund from our government, so either TechFi or StrikeFi. So we're okay with smaller company and small investment up to $2 million, but we also look for bigger money, about $15 million range. So that's it from me. Thanks so much. Any questions?
Perfect. And just to remind the panelists, don't worry, you'll go in a second. Just to remind the panelists, we'll go in order of hands raised. So if you want to throw your hand up, it's under reaction. It's under the react button. You can say raise hand. All right, Han, the floor is yours.
Thank you. Great presentation, and also congratulations on all the achievements. Great. This is actually it's awesome. When you enter, I know you're making a great effort to enter U.S. market, but are you trying to what are you trying to do in U.S. market? May I ask? Is that trying to move some of the R&D facility or manufacturing facility, or what are you trying to do?
Yeah, eventually it's manufacturing. We think, especially our DoD related display, a totally made in USA will be preferred by our customer. So I think one of the great way to invest us is really move the manufacturing, as not just for our industry, probably eventually going to benefit other industry as well.
Gotcha. So I know you're based out of Taiwan, right?
No, we're a Silicon Valley company. So we have a company.
Silicon Valley? Oh, okay.
Yeah. So our manufacturing partner is one in Korea and one in Taiwan. So we are also PAA compliant. Yes.
Gotcha. Okay, got it. I know. Are you going to be at Select USA in a month or so?
Select USA.
Okay, if you don't know what it is, I'm there as a speaker and also a judge. So I'll talk to you about offline. Okay, I'll help you out.
Thank you.
This is perfect program for you guys. I can tell that. Okay, so thank you. Appreciate it.
Okay.
I'll tell you more about it. Thank you.
Thank you, Han.
Perfect. Yvonne, you're up.
Yeah, thank you, Eric, for this interesting presentation. I saw, you had some very impressive logos on one of the slides.
Yeah.
And I was wondering how much you can share. For example, Microsoft, that just jumped into my face.
Yes.
Is this something, are you working with them on next generation product, or are you in serious production with them already?
It was a previous production with an existing product. I hope to have a chance to work with them, especially for head-mount display, but not talking to them yet. Yeah, so many existing product like large format display. So yeah.
Yeah, we were deploying to their retail locations with our current generation tech, the large format displays.
Okay, thank you.
Perfect. We have time for one more question, if anyone has. Otherwise, we can continue moving forward. But while we're yeah. So yeah, so in the interim, Eric, you want to leave your contact information? Eric and Jim, you want to leave your contact information in the chat? So
already done.
Perfect, beautiful. You guys are way ahead of me. Way ahead of me. Well, thank you guys so much for presenting. Love the presentation.
So as Victor, you want to ask a question? Sorry. Okay, I saw another person raise a hand.
Oh yeah, I see him now. I think he has to ask it through the chat.
Okay.
Yeah, I think you should reach out to him.
Okay. Thanks so much. Okay.
Yeah, absolutely. Thank you.
All right. Okay. Talk to you later. Thank you. Bye-bye.
All right. Next up, we have WaveWorks. Feel free to start sharing your screen whenever you're ready.
All right. Let's see, you should be seeing something there.
Yep, we see it.
All right. Awesome. So hi all, Aaron Parks, CEO at WaveWorks. WaveWorks makes unique hardware building blocks that let you move more data for less power in wireless connected devices. So, excuse me, our first chip reduces the amount of power needed for devices to send data wirelessly by 99%, while still being able to talk over 50 meters range and using standard protocols. So how does it do this? Conventional radio is kind of like a flashlight. We take energy from a battery, convert it to a radio signal, and actively emit that energy into the environment. Conventional radio is power intensive, it's complex, and it's expensive to implement. WaveWorks tech, on the other hand, works like a signal mirror. We reflect energy to communicate. It's smaller, it's cheaper, and it's dramatically lower power. So sensors really benefit from low power data transmission. We're building a peel and stick machine monitoring sensor that continuously streams audio from a contact microphone. It lasts a year on a small battery, and the rich data set that it captures throughout that year means far better insights from the large AI model that is digesting and processing that data. So normal wireless sensors are severely bandwidth constrained. So picture looking at a single pixel in the middle of a video and trying to figure out what's going on in the video. Right? This is the job faced by analysis based on conventional wireless sensors. We remove that constraint by making it nearly free to move a rich, low latency data stream over the air. So we're working with local manufacturers in our area to develop and trial out the system. Over the last couple of months, we've actually segued into a key relationship with a major manufacturer of steel products. The learnings from that have really been invaluable, both in validating our hypotheses around the system that we're building and also just in developing the product itself. So in addition to machine monitoring sensors, other areas where more data for less power is valuable are in peripheral devices for consumer electronics, asset tracking and monitoring systems, and wearables. And in each of those cases, we're bringing the ability to move far more data over a longer battery life. And again, this is lent by that unique fundamental new technology that we bring to the table. So WaveWorks has actually been really fortunate to work with many corporate product teams and R&D teams ranging from startups to top 5 tech giants. We're excited to be seeing common pain points around wireless connectivity solutions crop up repeatedly across industries. So we know there's a huge greenfield opportunity for low power wireless chipsets. There's a number of others playing in the low power wireless comm space, of course, but we think we're bringing something really unique to the table by applying some of the techniques that are conventionally reserved for like RFID applications to more conventional radio systems. So we're kind of bringing together those two worlds. We're right at the intersection of those worlds. And we think we have an interesting niche that serves a lot of applications that are traditionally underserved. We've also been able to generate significant non-dilutive funding through work done for these customers, as well as through multiple federal grants and contracts. Actually, we were just awarded an Air Force Phase 1 SBIR, an AFWERX SBIR, which is essentially funding us to perform a technical feasibility study around an application customer within Department of Air Force. We've also engaged actually with a prime defense contractor who has provided a letter of support to seek a larger Department of Air Force contract. So our team includes hardware gurus with many decades of collective IoT experience, an AI expert, and folks with foundational expertise in wireless power. I co-invented the core tech used by WaveWorks to get to ultra low power. Our IP portfolio is very strong with 27 issued patents across 11 patent families. Most of these are secured through an exclusive global unlimited term license agreement with the University of Washington, which is where some of this tech was initially conceived of. These cover a really unique set of capabilities. It's really not easy to replicate what we have, so this all creates a pretty strong moat around everything we build, including the machine monitoring solution I mentioned. So right now we're raising a $5 million round to support product development efforts toward the machine monitoring solution I described, as well as a next generation integrated circuit. Hardware's hard, and silicon's not cheap, but we feel that the moat that you can build using our unique capabilities is very strong. So I'd love to chat further if this is of interest to anyone, and happy to field any questions.
Perfect. Thank you. Thank you so much, Aaron. So feel free to, yep, Yvonne, go right ahead.
Thank you, Aaron. So my understanding is you have like a unique protocol and technology to transfer data from, like a sensor, a battery-powered sensor you strap on a machine to the backend.
So, yep, yeah.
So I have to put a specific like chip also in the receiver, or can I integrate this IP into an existing chip easily?
Yeah, absolutely. So the IP exactly is around the low power connectivity methodology. So moving the data from the sensor to the gateway device by way of this reflections, right? It's backscatter communication is the technique that's used. This is a technique. It's kind of initially, it's in some ways borrowed from the field of RFID. RFID tags are, battery-free, ultra-low power devices that are powered wirelessly by the RFID reader's radio signal. They use backscatter communication to get to that ultra-low power. We kind of co-opted that technique and said, hey, we can do a lot more with this than just replacing barcodes, right? We can do a lot more with this than barcode replacement. We can talk Bluetooth, we can talk Wi-Fi, we can talk LoRa and Zigbee and other protocols. We can actually talk standard protocols using that ultra low power technique. So that means we can actually interoperate with commodity chipsets and infrastructure. In some cases, existing deployed infrastructure with a firmware update can be used to interoperate with our device. In other cases, it's depending on the application requirements, there can sometimes be additional hardware requirements at the sort of gateway or base station side. But absolutely possible to achieve, we often talk about the holy grail here is direct to smartphone connectivity from something that looks more like an RFID tag. And that is something that we expect, with the right partnerships is achievable. Given all the radio resources and capabilities on modern smartphone. So I hope that answers or kind of gets at your question.
Yes, thank you.
All right, Eliza.
Thank you. Can you move back even one more slide? That the image with the, there you go.
Think about this one. Yeah.
Yeah. So is it continuous or is it triggered by something? The transfer of the data.
So the base station side or gateway side has to mediate the transmissions that the low power sensor device is making. So you can think about this as a little bit different than a conventional radio paradigm. In conventional radio, as long as the receiver's listening and I transmit, it's going to hear me, right? But the receiver does need to know when to listen, right? So you still have to coordinate timing to some extent. In our paradigm, the receiver and the infrastructure around it also needs to, in addition to listening for the signal, it also needs to have some way to generate what we call the illumination signal. That's this guy over here, this magic, or maybe I'm not, yeah. So Nate, hopefully you can see my cursor there. So this magical little flashlight here has to be somewhere in the environment, right? You have to illuminate this thing with an RF signal for it to be able to talk back to you. So you do provide that illumination, and in conjunction with providing that, you also provide a wake up signal. So you're saying, okay, wake up from a deep sleep state. And I can also provide some commands. I can provide a downlink. So I can communicate with this low power device down here and fully mediate everything that it does. So yes, it does require that type of coordination from the base station or gateway side. And I realize the paradigm is a little different than conventional radio, so it's a little hard to wrap your head around. But would love to talk about integration, what integration looks like around a specific application space. That'd be helpful.
Right. So can I have a follow-up question if I have the time? Is that okay?
Sorry, I was muted. Go for it.
Yeah. So Henkel is active in predictive maintenance. I mean, our materials are used in maintaining a lot of the machinery, and predictive maintenance is a new business model for us. I'm just wondering who you're collaborating already with in that space, or you have team members from the industrial sector?
So we are primarily, so we're building something fairly new on the analytics side that pairs with our, again, very unique sensor system. So we're building the hardware to support the sensing operation, and we're also building the analytics to support, digesting and driving insight from that rich data set. We are in conversations with a couple of folks. I don't know if I'm supposed to name names at this point, but we're in conversations with a couple of folks who have the existing, I could think of them as channel partners, really, who have the existing manufacturer relationships. But at the same time, we're also diving out and going direct to, again, local manufacturers. And then I mentioned we're segueing up to, a very large local steel manufacturer of coated steel products that ships, untold many millions of product monthly. So these are some ways that we're kind of developing the product and business and discovering our customers and trying to find our fit as we go forward with the machine monitoring system development here. Now this machine monitoring system is built around the core technology that I described. It is a beachhead application that I think really demonstrates and hopefully thoroughly demonstrates why you'd want to use our core tech and where it's generally useful. It is not necessarily the entirety of our business at the end of the day, but right now it is the main focus.
Okay. So you're basically taking care of the data transfer part of these sensors. Are you collaborating already with maybe to focus it's more of a recommendation, I guess. Are you collaborating already with the sensor companies that are picking up on the data and things like that? It's just a comment.
So we do have a relationship with a couple of companies that are doing the sensing side already, but in fact the sensor modality that we're using is unique. So it's actually an acoustic sensor. It is not something that's used today. So you can picture this as literally a mechanic's ear. Pictured your most skilled operator or mechanic sitting next to that 5-axis mill or that that combustion fan or that whatever it is, the thing that is the bane of your team's existence, right? And the thing that drives them nuts when it fails and takes the whole line down. Imagine your most skilled operator sitting next to that 24/7 listening. They always pick up on it if they're literally there on site listening, right? So this is the insight that led us to acoustic monitoring. The data requirement is tremendous to be able to move that much, to move audio, basically a continuous audio stream across that link. It's a lot of data. And that is where our unique comms tech kind of builds that interesting moat, I think, around this.
So you are sensing in essence yourself. Okay.
We
All
are
right.
doing
Thank you.
Sorry
All right,
to
now-
cut you guys, but we're gonna have to keep moving.
you.
Okay.
Elias and Martin, sorry that we couldn't get to you, but basically feel free to reach out to Aaron offline or even in the comment chat section here. Feel free to go back and forth. We're just running a tight ship, and I know some folks have commitments on the hour, so I'm trying to get through everything. Thank you so much, Aaron, and definitely leave your contact information.
Okay, will do.
Yeah.
Thanks.
All right. Next up, we have Xcelerium.
All right.
How's it going, sir?
Let me know when you guys see my screen.
We can see it. It's not on presentation mode yet.
It's gonna be there in a sec.
Perfect.
Can you see it now?
Yep.
Excellent, and thank you for basically hosting us today. Xcelerium, we're a fabless semiconductor company, and we're building accelerated compute for AI-enabled sensor processing. We have made tremendous progress so far. The company was founded in 2020, late 2020. We're all about bringing intelligence and processing for high bandwidth sensor processing applications, and these will be communication, RF sensing, radar, as well as camera. Target markets, it's at about $25 billion in TAM. We are generating revenue. We have generated more than $4 million of revenue so far, and we are on target for design wins that could amount to about $50 million per year in revenue. Everybody when you take a look at the intelligence needed, especially for autonomous systems and what have you, you have the edge servers, and then you have the devices, and you have the sensors. And in many applications, especially for autonomous systems, you need to push high performance compute as well as the intelligence into the sensor from that perspective. Sensors are becoming more complex, generate a massive amount of data, and you need to be able to process, fuse close to the sensor, and make a real-time decision next to the sensor in many of these applications. So that brings quite a bit of a challenge, because if you want to do that, then you have constraints from a power and size and form factor. And as we know, like AI model as well as the advanced signal processing techniques, they keep evolving. So you cannot really hardwire some of these signals. You need something to be future-proof and to be innovative from that perspective. By bringing capabilities of high performance compute and signal processing and fusion at the sensor, you can do new capabilities from that perspective. You can improve the performance, for example, for imaging radar in a significant manner. You can do RF sensing. You can even make your modem as a sensor. You can do RF fingerprinting, from a security perspective. You can do tracking. You can you do like a precise positioning and location. If you take a look at how people doing the architecture today to add compute, you have the ASICs, you have the GPUs, and you have the FPGAs. And from an ASIC perspective, they're great from a swap perspective, but they're not really great from a flexibility or resilience, and they're only good for high volume application. But today, if you do a chip in 3 nanometer or 5 nanometer, it takes you probably 3 years to do it. It costs you probably $150 million, $200 million to do it. And God forbid, if it's not really optimized for the application that you're doing it, or the new AI model came about and you cannot support it efficiently, then you're in a big trouble. GPUs are wonderful today for using AI machine learning processing, but they have an issue with latency and power and resilience. And I was talking to a CEO of a robotics company, and he said he's using NVIDIA Orin. But he indicated for many of these applications, NVIDIA is great for prototyping perspective, just to make sure concept-wise. But from a size and power perspective and even cost perspective, it's prohibitive for many of these applications. And so you need flexibility. I mean, if you listen to Jensen, he mentioned that NVIDIA, they did their compute, and they just happen to be great for graphics, but they're all about accelerated compute, and that's why they're actually winning. They're saying people could optimize for CNN, RNN, transformers. Things keeps evolving, and you really need a solution that actually can adapt for the future from that perspective. So we believe that is the trend: accelerated compute, give it the flexibility. FPGAs, on the other hand, are used especially in aerospace and defense because they provide the flexibility, the latency, and the resilience, but they're bulky. You can't use them in certain location. It's actually prohibitive, and I can talk about some of the challenges that we're working with aerospace and defense to help them with. I don't want to go over this in details, but we are the only processor that replaced CPU, DSP, and AI accelerator. We have basically patented, basically reconfigurable compute to enable the machine to work on different modes, as well as being able to efficiently doing vector processing, as well as an AI machine learning, baseband, and complex control. And that's really, really very helpful, because lots of the power gets consumed by moving the data around within the chip or outside the chip. So if you can actually localize that basically processing on the chip, you reduce the power significantly from that perspective and improve the performance. I'm going to give you just a high-level benchmarks in here. The Qualcomm Snapdragon, these are publicly available data. That was for a project that we did for NASA. We have to compare. And we picked 2D-FFT as one of the functionality. We have more benchmarks about AI and machine learning. But take a look at that. I mean, like even a hexagon DSP, our solution, which is DRSAB, which is the first column from that perspective, we're about basically 30 times better in power efficiency than the specialized DSP. from that perspective. And if you compare it to the GPU, we're about 133 times. Even if you compare it to Sci5 280, which is one of the state-of-the-art vector processors, we're about 42 times more power efficient than Sci5 from that perspective.
30-second warning.
Okay. Anyway, we have many applications, from that perspective. Distributed radar is one of them, and we have in-band communication that goes with the radar. We having great traction with aerospace and defense. We're working with 3 primes right now, and with aerospace and as well as Space Force as well as the Navy. So here's the summary. We're developing accelerated compute. Market opportunities are huge. Our initial focus on aerospace and defense and wireless, followed by industrial and automotive. We have proven product market fit. We have close to design wins that they're going to generate more than 50 million a year. We generated $4 million already. We have highly efficient operation led by an experienced team. Sorry for quickly, and thank you for the 30-second warning.
Absolutely.
That's it.
All right, perfect. Martin, go right ahead.
Hi, Nazar. Thanks for the presentation. How do you guys fit in with the existing tool chain? So if I'm working on an existing product that has a GPU or an FPGA in it, how do I, if I need to work with you guys, do I need to rebuild my tool chain, or can I keep using Python and
Okay, so no, you can still use, because it's the presentation is 10 minutes. Our processor is RISC-V ISA compliant. We have our own specialized, and we provide libraries. And we're actually already working with multiple customers on the wireless infrastructure side with 3 big primes actually. And they use just off-the-shelf tools, and we provide them libraries, and they'll just take it from there, from that perspective. So being RISC-V ISA compliant enable you to use GNU debugger, all the tools, the math libraries and what have you. And we provide very simple libraries, for customers to tap into to our acceleration from that perspective. Does that answer your question?
Yeah, that's very helpful. Thank you.
Yeah, and I'd be more than happy if you want offline. I can show you all the tool chains and what have you. We can schedule a discussion on that.
Yeah, sure. Thank you.
Perfect. Han, you're up.
Well, thank you. Hey, great presentation and very impressive team. And it's great. I think this is what market needs. I want to just know a little bit more about how you plan to, what kind of guard you put in place for your intellectual property, on the patent stuff.
Yeah, both. It's trade secrets and patents from that perspective, correct? So it's a combination of both from that perspective. It's very hard, we sell chips, correct? So it's very hard for people to reverse engineer, from that perspective. But we have also patents from that perspective. But I think a combo of both are the best way to protect.
Okay. Are you US based or US based?
Yes,
or what?
we're in Southern California. We're in Irvine.
Irvine,
Orange County.
Okay.
Yes.
Right. Okay. All right. Thank you.
All right, Mark, last question.
Sure. I actually have 2, if it's okay. Where do you make your chips?
Right now, TSMC, but working with the government, they want us to go to Global Foundry 12 LP. Right now, it's TSMC 12.
Okay. And are you going through the which level of space certification are you pursuing? Class A, B?
Actually, it's going to be Class B, but first we're focused on, we're working with the Air Force as well as the Navy, and then the next step will be with the Space Force into getting the certification for B. But the first one will not really be aerospace basically certified, the first generation of the chip.
Nasser, I think I have an older presentation of yours. I'd like to get an updated version of that, please.
Absolutely.
Yep.
We're working. Things are really progressing very well. From that perspective, and we expect and we hope to be on every warfighter, in the U.S. across.
Sure. Yep.
Perfect. Thank you so much, Nasser. And leave your email in the chat. It looks like it would make a lot of sense to you. Michael,
sure.
Howdy.
Howdy.
Let me just share my screen. Thank you, everybody, and thank you, Asher and Brian, for this opportunity here. I'd like to introduce myself. I'm Michael DeLeon with Edmund Scientific. We're a service-disabled, veteran-owned small business doing various RDT&E efforts for the U.S. government. And I'm going to be talking about remote advanced manufacturing of electronics. So basically, we're in the Industry 4.0 stage, which includes advanced manufacturing. Early additive manufacturing or 3D printing machines were used, predominantly for prototyping with polymers, metals. Now we are combining a multitude of materials that can now print electronics. These advanced manufacturing machines allow for highly customized small volume electronics to be printed, as well as allow companies to do distributed manufacturing. However, with highly customizable prints and distributed manufacturing, one of the major issues in advanced manufacturing is the shortfall of well-trained and well-experienced designers, engineers, and operators. Here we provide a solution to aid in the advanced manufacturing of electronics across distributed manufacturing facilities. Don't know why my arrow's not working. Where we've worked with the U.S. Army in developing our digital twin of an advanced manufacturing facility. This is to support expeditionary forces where facilities will be set up to manufacture components out in the field. And with the lack of experienced workers and designers and engineers, they wanted to have engineers in a centralized location, or at least a little bit further back from the front of the field, to support distributed facilities. So with augmented and virtual reality of the facility and ties to various machines and robotics, the centralized experts can help set up, monitor, troubleshoot, and help operators on the ground with prints and the various machines. We've also taken this technology to produce the capability for collaborative design and a shared space for people to work together on visualizing components and print steps so they can work together to optimize the printing process. And a web portal was designed as an overview to the machines and print status displaying in real time with historical charting capabilities. As a use case example, with a coupled line filter with a straight flat substrate and metal traces, where any deviation in the print can result in dramatically different performance characteristics. In the actual advanced manufacturing printing phase, remote operators would be able to leverage remote access to the machines to provide process monitoring. Here's just one of the machines. It's an end script used in part of the print process to lay the substrate and some of the traces before it's picked up by a robotic arm and put into other machines in order to attach or put in that coupled line filter in series on some kind of other component. In our testing, we found various steps and items, however, that could be improved. Setting of the heights, for example, on the substrate, for the substrate deposition, for the trace deposition, or just the milling of the surface in order to get a nice flat surface for the substrate itself was extremely manual. Also, the micro dispensing tips for the substrate and for the metal traces could have some issues with overloading or underloading, which creates different problems during the print process. So, in summary, and in our next steps, we would like to expand this remote access service package with additional machines, additional features, and also, as a next step, develop in situ optimizations that make it even more robust for experienced engineers to be centrally localized, and the operators would have require minimal effort in order to make sure that the printing process is properly done. We're looking for mentorship and sponsorship to market and commercialize this Advanced Manufacturing Center Remote Access Service Package, and any funding to support expansion, load testing, physical optimization of the tooling for the advanced manufacturing machines. And I didn't even get Asher to say 30 seconds.
Nice. Yeah, you're good on time.
Thank you, sir.
Perfect. Yeah, absolutely. All right. Questions? Feel free to raise your hand whenever you are ready. All right, Elisa.
Yeah, so just to clarify, you're planning on offering a service for remote manufacturing. Is that
Yes.
correct? Okay.
Since each distributed manufacturing facility would have its own, regiment of machines, there's going to be a lot of carryover from our previous models over, and then we'll have some customization to be done in order to match their facilities.
Okay. And the samples will be shipped to the customers? Are you focusing on a certain geographical area, or what are your plans there?
Anywhere in the United States.
Okay. Any partnerships that you're thinking of?
We were
Different foundries?
not so much foundries, we're more on the government side, so we were reaching out to the Marines to extend the expeditionary forces aspect of this service package. But it is definitely on our minds, and we just haven't made the connections yet.
Okay.
Asher, can I ask a question? I can't figure out how to raise
Go
my
for
hand
it.
here.
Go for it.
Yeah, Michael, thanks for your presentation. It looks like primarily fee for service. As investors, we do need an exit. How do you plan on exiting Edmond and providing funds back to the investors?
Honestly, I'm not a money guy, I'm more of the scientist. My apologies. That is not something that's in my wheelhouse.
All right. Yeah, and I'm sure, Michael, over email you could probably sort that out. All right.
Of course.
Yeah, next questions. Mark, go right ahead.
Yeah, hi. Are you going to go into like the build to print services? So like if we had a design, we could send that to you and you would print and manufacture these?
So what we've seen are the build to print services market growing, and that is the market that would be a market that we would be supporting to reduce their costs on workforce.
Okay.
Perfect. Han, you're up.
All right, good. Hey, great, good presentation, and I like your concept and the idea of your product there. How long you guys been around? How long you guys been doing this? Edmond Scientific.
Edmond Scientific has been around since 1998.
Okay.
We support various DoD and Veterans Affairs divisions.
Okay, because I thought I heard about you before. That's why I was asking. And the second question that I have, yeah, good. Are you guys on this specific products and you were talking about? Are you guys it has to be in compliance with the ITAR in case you talk to some other parties overseas, or not? Is your product
Currently not.
ITAR? No,
this is not
okay.
ITAR restricted. Nope.
Oh, okay, gotcha. Okay, alrighty. Yeah. Plus, maybe talk later here. Thank you. Appreciate it.
Excellent. Thank you very much, Han.
Perfect. Perfect, Michael. Feel free to leave contact information in the chat. I know it's on the slide also, but just in case before we hop off. Otherwise, anyone who wants any information, feel free to email myself or Brian. We are more than happy to connect, join, and everything. I have to thank all of the companies that presented and all of the panelists who joined for a fantastic event. And we really appreciate all of the support and all of the participation. So have a great rest of your day, everyone, and thank you again.
Thank you.
Yeah.
Thank you.
Yeah.
Thank you.
Have a good one.